Okay, ta-da! This section is easy, or I think I think it's easy. Okay, it's combination of functions. And also we're gonna talk about composite functions. Now, first of all, we talk about the combination of functions. If you have multiple functions, you have a f, you have a g. Remember, we might have a h, k, l, m, n, o, p, q, r, whatever. So we have a lot of functions, and we can define a new function. Okay, that's the algebra of functions. We can have a sum, we can have a difference, we can have a product, and we'll have a quotient function. What is the sum function? Sum function of f and g. We write it this way. Okay, watch. I'm going to write f plus g. That's a new function. That's a sum function. We just use f plus g to show it, of x, which is just f of x plus g of x. So I told you it's easy, right? And the second one is the difference function. Of difference function of f and g, which is just f minus g. Again, this note, f minus g, is a new function. It's called a difference function. Okay, and that is just the difference between these two functions. Just write it that way. And a very similar, the product function. We write this way. Okay, watch. I write f g of x. Again, this is a note for product. So that is product function. So it's f of x times g of x. You might think this is so straightforward. Yeah, but the hard part is you got to understand this is a function. Okay, it's just a different note. We just use this as a note to show that that's a new function. So it's not a distributive. Okay, it's not a distributive property. All right, now the last one is a quotient. Okay, quotient function, which is f over g of x, which is f of x over g of x. Now, every time when you write this, you got to be really, really careful about the denominator, and the g of x cannot be 0. Okay, remember, as your professor, as your math professor, I tell you there's something that I don't like. I don't like a 0 in the denominator. I don't like negative numbers inside the square root sign. Can you remember that? Okay. Now, if you're okay with this, we're going to work on an example. So I give you several functions. I give you f of x equals 2x squared plus x minus 3. And I give you g of x is x squared plus 9. And the third one, h of x equals the square root of x plus 1. Those are given. Now I ask you to find what is f plus g, this sum function. It's just the f of x minus g of x. This is the definition. And then the next step is you're going to put in 2x squared plus x minus 3 because f of x equals this. That's given. And then we're going to minus g of x is x squared plus 9. Okay, see what I'm doing here? And then after that, you're going to expand or get rid of the parentheses and simplify. So you have 2x squared plus x minus 3 minus x squared minus 9. And then combine like terms. 2x squared minus x squared, we get x squared. X, that's the only term here. Minus 3 minus 9. Minus 3 minus 9. Did I say that? Minus 3 minus 9. Minus 12. x. Oh, sorry, I did a minus. Okay, sorry, let me change it here. Okay, then I do plus. I'm sorry. Let me just find the sum function. Then that'll be just f of x plus. So this is easier, right? We did the hard part. And then now it's 2x squared plus x plus minus 3 plus x squared plus 9. Therefore, that's 2x squared plus x minus 3 plus x squared plus 9. Combine like terms, I get a 3x squared plus x plus 6. Phew. Okay, so that's the sum function and the difference function. And then can you find more? Can you find fg? X, which is just f of x times g of x, which is 2x squared plus x minus 3 times x squared plus 9. Then you're going to use the distributive property. That's hard, right? So you're going to use this guy, multiply by every single term there. So that's 2x squared times x squared. We get a 2x to the 4th. And then that's plus 18x squared. So 2x job done. X distributing to that, I get a plus x cubed plus 9x. And then the last part, I'm going to distribute this negative 3. So minus a 3x squared minus 27. Okay. Are you ready to combine the like terms? For the 2x fourth, that's only fourth term. And the cube, there's only one cube term. And there are two square terms. So 18 minus 3, so that would be plus 15x squared. And there's only one x term and then minus 27. So that's my answer. So that's FG. Okay, not done yet. And can you give me f over, let me just do it here so you can still see them. Can you give me f over g x? This is a quotient function, f over g. All right, that'll be just 2x squared plus x minus 3 over x squared plus 9. You can leave it like that because both numerator and denominator have the same power. I don't want you to the same degree. You don't need to simplify. So that's f over g. Two more. Okay. So f plus h of x. So here's f, here's h. So that by definition is this. So that's 2x squared plus x minus 3. And I'm going to plus the square root of x plus 1. Can you simplify this? No, that's it. Leave it. Last one. F over h. By definition, there will be f of x over h of x. And f of x is 2x squared plus x minus 3 divided by, now the h is the square root of x plus 1. All right, now, can you remember there are two things math professor, as me, we don't like? I don't like, number one, I don't want 0 to be the denominator. I don't want a 0 in the denominator. So far, nothing happened like that. Second, I don't want the negative number inside the square root. Third one, I don't like to have the square root in the denominator. So what do you do if you have a square root in the denominator? Every time when you see this, you say, oh, Professor Wu is not going to be happy about this. So you have to make that multiply by x plus 1, square root of x plus 1, both numerator and denominator. You're literally multiply by 1, right? Numerator and denominator are the same thing, so you're multiplying by 1, which means you can write equal because you're not changing the value. But the good thing is this square root times the square root, it becomes just x plus 1. Hey, what Professor Wu doesn't like is gone. The numerator, we have 2x squared plus x minus 3, and then we have a square root of x plus 1. at the end. Or you can leave that in the numerator. You can put a parenthesis and then put that on the top. That's okay. But this is good enough. All right, so I told you this section is going to be easy, right? That's called the combination of functions. The combination of functions including adding, subtracting, multiplying, and divided by division. Now, what about this one? What about the composite functions? Composite functions is basically a function of a function. What does that mean? Composite functions. That is something very new to you, okay? Composite function. Function of a function is this. F circle G. What does that mean? This is a new function. So the function of x. What is that? What is this little circle? F circle G. It's not fog, okay? It's not fog. It's F circle G. What it is F of G of x. Never seen this before, right? Okay. I give you one example. F of x is given as this. It's a 3x minus 4. G of x is x squared minus 2x plus 6. See, I give you F and a G. Can you find F circle G? All right. Now, F circle G of x should be F of G of x. I tell you what to do. You don't know this. This looks too complicated, but do you know this? G of x? G of x? Do you see that? Yes. So I just put that in x squared minus 2x plus 6. Is that okay with you? Starting from inside, just substitute that by the given function. So you get f of, instead of having f of g, you have f of x squared minus 2x plus 6. Okay, so now go back to here. You have f of x is 3x minus 4. Do you remember long time ago I said f of something, it's 3 that thing minus 4, right? Right now we use it. It's f of this guy. It's a long term. We put in here and then we put in there. So that's going to be 3 times x squared minus 2x plus 6 minus 4. Now life is easy. Okay, now you can just go ahead, simplify, distribute that. You got a 3x squared minus 6x plus 18 minus 4. Again, combine like terms. You have 3x squared minus 6x plus 14. Done. That's your new composite function. So what do you think? Okay, composite function f circle g of x, which is f of g of x. Do you remember I told you is function of a function, right? So that's how it works. But inside, we already know this function, which is simply the first step is always easy. We just put in whatever, substitute this by the given function. And then the next step you have to perform, you have to do something, you have to put in the F magic box. And then you go back to what we learned. And then very early step about this definition of a function. So that's the f of a g. Can you give me g of x? G circle f. Can you do that? Okay. F circle g is f of g of x. G circle f, which is g of f of x, like that. Again, we substitute this first. So we get a g of, because we know that's a 3x minus 4, right? Nothing wrong. And then g of something, see, g of something will be that thing square minus twice of that and then plus 6, right? That's given. It's like this. Instead of having x, because here's x2, I don't want you to get confused, so I put, instead of x, I put a box. Okay, so that might be an easy way to do it. So that will be the box square, so which is the whatever in the box should be this guy. Square minus twice of 3x minus 4, and then plus 6. Okay, can I continue? So 3x minus 4, you either use this a minus b square, which is a square minus 2ab plus b square. That's one formula. Or you can do 3x minus 4 times 3x minus 4. Use the FOIL method. If you don't remember the formula, you can use the FOIL method, okay? And then next one, you can do distribute this 2, so you get a negative 6x. Negative, negative, you get a plus 8, and then you plus 6 at the end. So we just need to do FOIL. 3x times the 3x, which is 9x squared, out negative 12x. You see that? 3x times 4, right? Negative 4. And then 3x, negative 4. So another 12, negative 12x. Negative 4, plus 16. And then I go minus 6x. 8 plus 4, I can do that. 14. Excuse me. Go ahead, combine like terms. 9x squared. So this is the x, and x. So negative 12 and negative 12, which is negative 24. And a negative 24 minus 6, negative 30. And then plus 16 and 14, which is plus 30. Bingo, we got it. All right, now I want you to go back to check. This is your F circle G. F circle G looks like this. 3x squared minus 6x plus 14. But G of x looks like this. 9x squared minus 30x plus 30. They're different. So what you can tell is G circle F is not always, okay? F circle G X. That's what I want you to get this concept. All right, now, last one. Can you help me to find G circle F? 1. Can you do that? Why not? Remember, this is a G circle F. X equal, right? So I just need to substitute, I just need to substitute 1 here. So that would be 9 times 1 squared minus 30 times 1, and then plus 30. So what's the answer? There you go. Or the other way, G circle F, which is a G of F of 1, right? Okay, so what is F of 1? Remember, F is here. Okay, sorry, where is F? Here. F of x is 3x minus 4. So F of x is 3x minus 4. So what is F of 1? That will be 3 times 1 minus 4, which is negative 1. So that is a G of negative 1. And what is a G function? The G of x is this, right? So G of a negative 1, we plug in negative 1, we get a negative 1 squared, which is positive 1. And here's a negative 1, so negative 2, negative 1, which is positive 2. Positive 1, positive 2, positive 6, 9. We get the same answer, okay? So now you see the composite function, how it works, and the F circle G is not the same as the G circle F. All right, so I told you this section is pretty easy, and I think you already understand the combination of functions, your sum, difference, product, and quotient, and the composite functions, the function of a function, and what do they mean, and you know how to deal with it. And I think you're ready to do some exercise.